Hello, my name is Walter Rustler and I will present this webinar today to you. Today's webinar is about tips and tricks using RFEM. We will cover useful functions. We will also take a look at some new features in RFEM 5 and we will also address frequently asked questions. In this webinar you can ask some questions using the control panel of the webinar software. You find here a questions section where you can type in short questions. Please keep the questions short. My colleague Robert Vogel, who is also online, will answer them briefly during the webinar. If we cannot answer all questions during the webinar, we will follow up with them after the webinar. We'll right away go into the live presentation and I will switch to RFEM just now. In RFEM, I will show you today some what I think helpful things. We will not be able to cover everything, but we'll have quite a good selection of it. The first feature I want to show you is about handling dimensions. You find the dimensions commands here in the toolbar to the left, and you have linear, rectangular, or angular, or slope or height tools that you can use for dimensions. I have here a simple truss structure, and I can add some linear dimensions. For example, you just click on the individual members here, and you can place the dimensions by clicking in the workspace. Same way, you can also enter linear dimensions by clicking on members or on help nodes that are created during the when you hover over the members. Beside linear dimensions, you can assign angles. I use the angular tool here and I click on the two members that form an angle, and then you can place the angle dimension anywhere you like. Another option is to work with slopes. So if you have a roof that is not horizontal, typically it has some slope, you can just also put a dimension line there, an angle, by selecting on the sloped member. And a new feature in RFEM 5 is to deal with height symbols. For example, if you want to add a height symbol, you can click on the node and place the symbol anywhere you like. And now it shows you the dimension 6 meters or so. This member is only 1.16 meters. How to change this, or why is it 6 meters here? When you edit it, you can enter here a reference height, and I had done it before to -5 meters. If I set it to 0, the value will change. If I enter here the offset, for example, if the building is 5 meters from the origin below, then you have the level of 6 meters or 7 meters 7 meters 16. Those are useful things that you can use to work with your printout report, or when you talk to your designers, then they can grab those measurements, or you can assign those measurements in your graphics as well. Additionally, you can hide and show individual dimensions. For example, if you go to the display tree here, you can scroll down to the guide objects, and then you find dimension, and you can unfold this tree here, and you see for each dimension there is an individual item, and you can check it or uncheck it. And so this way you can maybe add several dimensions, and if you use them, if you need them, you show them or hide them. You can at any time edit the dimensions, and you can also assign some labels or symbols with it. For example, if you have an angle, you can also assign here a Greek letter, which is alpha 45 degrees, for example. At the same time, you can enter, for example, or you can show the unit, and it will be written into the symbol. Sometimes you maybe want to work only with user-defined labels, so you can do this also here, edit, and you say here reference label. This is not user-defined, but it's a reference label, which means there's a program constant that is used to place in front of the dimension. Or you can use a symbol and you can write here something that whatever you like, lengths maybe, no? And then it will be placed in front of the dimension. At the same time, you can also use tools and measure, which works similar, and you can inquire different information, different distances, angle between 3 nodes, angle between 2 members, angle between 2 surfaces. For example, if I say acquire angle between 2 members, click on the 2 members and you get some information like what is the angle. So you don't have to place actually a dimension line there. Okay, this was the first small feature, and another feature I can actually show also on the same structure is what we call finding out the centroid. To do this, I select the entire structure, I right-click on the selection, and I find the center of gravity. If I click OK, I get information about the location of the center of gravity. I find also information about lengths, surface of coating of members, volume, weight of the material, and so on. I also can create, I see the center of gravity here with an arrow, I can create automatically a node there. And you can use this information if you want to lift, for example, this structure with a crane. You know where you have to place your cables or your lifting equipment, so the structure is in balance when you lift it. You can do this also with only parts of the structure. So you can find center of gravity also here. You just find it, okay, the center of the selected part is here. Okay, this is what I wanted to show you on this structure. Now I'm opening another structure which is similar, which is the centroid surface, it's called, and I open it, and here I show you, first of all, again, centroid works also here. You can right-click on the center of gravity and info. Same way here, you find here an arrow, can create a node. It's the same way. What you see here is a set of surfaces, and I have displayed here already the lines, the coordinate systems of the surfaces and of the lines. You can display them here in the display navigator under model, and then surfaces. You can show the surface axis system, which is here, and you can show the line axis system also if you unfold here the trees. So why I'm showing this to you, if I run the analysis, you will see here some maybe unfamiliar or not so nice results, which are inconsistent here where we touch those two surfaces. The reason for I'm showing now mx, which is the bending moment that creates stresses in x direction, and The x direction is the axis, or that is the refers to the axis system of the surface, which is shown here. So all these stresses act in x. Why is here this discontinuity? It's because the orientation of the surfaces is different. Here goes downward, here goes upward. How to fix such things? You select the surface, right-click on it, and you have the option to reverse local axis system. So it will revert the local axis system of the surface, and the local z-axis goes down now, as with the other surface. Okay, the same thing you can do with the lines. You see here it goes downward, here it goes upward. Also the orientation, this line, x direction goes this way, here it goes in the opposite direction. So I want to have a continuous flow of this line, so I can select the line, reverse line orientation. Do this the same way on the other side. Maybe here it's not possible or not necessary. Okay, I can do it in this way as well. Reverse line orientation, and now there's a continuous flow. With the lines, I can also work with rotations. You see here, this line direction goes downward, this goes upward. The reason for this is there is a rotation in this line, beta 180 degrees. I set it to 0, and I do the same thing over here. So you should know you have those options, and what is the result when I analyze the structure. I run the calculation again, and we have there a surface load, a constant surface load on that structure. It's just a regular block load, and you see here now we have a continuous flow of the internal force. So all the neighboring surfaces, when you show mx, you actually look in the same direction. But what if I want to have the results referring to the curved structure? So my mesh should follow the curvature of this structure here. How to do this? You can direct the local axis of the surfaces individually for each surface. And you find here the axis table. And in this axis table, you can set the axis for input and for results individually. Standard is it will follow the axis system of the surface, which is defined more or less by the program itself. But here you have the option to direct the axis, the local axis of the surface, so that it follows a parallel line. And I pick this line and I say, okay, it should follow this line. Okay, it will erase the results, and you see here the axis system of the surface followed, and I do the same thing here with this surface. Axis x should be parallel to line this one. Okay, when I run the analysis now and I take a look at the results, we get a quite different picture again. And especially if you look at my, which are bending moments that create tensions in y direction, you see there is a nice parallel flow of this my. And it's quite important to understand this, how the results are, which directions they refer to. In the same, and actually if you do this, you have to be aware that all your rebars, if you have, for example, reinforcement, it will follow also those coordinate systems. You see here also the support, the supports are also oriented in this global coordinate system. If you want to, you can edit it and edit the type and then refer to local line axis. And you will see also the supports will then be oriented following the curvature of the line. So when you print pictures of results, make sure you check the orientation of your surfaces. Here it is quite simple. If you have a surface that is in general position in space, it might be not so clear anymore where is y, z direction and so on. But you have all the options inside RFEM. Okay. Next example will be about friction. I open another example which is called friction. So this is a simple frame structure. It has a couple of load cases with gravity and live load and one combination. And I have here a fixed support, pin support on both on all three supports. But now I want to enter here a support that has friction parameters. So maybe it's not a fixed support, maybe it can slide here depending on the axial force that is applied to this support. How to do this? I double click on the support to edit it and I create a new type of support. And for each support condition I have here non-linearities. And new in RFEM 5 are friction properties, and we use here friction depending on the local PC force. If I do this, I have here the option to edit the friction parameters, and here you get the option to enter the friction coefficient. So the maximum force in px will be this friction coefficient multiplied by the PC force, also vertical force. Okay, if I assign this support here, you see here is a small symbol that tells you there is something different. And if I run the analysis, I should get horizontal forces not bigger than 10% of the vertical force. And if I take a look at it, I have the vertical force 64 kilonewton and the horizontal component is then 6.47, so 1/10 of this. And we see here also it's not fixed. There is this movement of this support. Same situation with just live load. There's just less of force. You see here nonlinear behavior. So it iterates and it recalculates the spring constant in each iteration. And you see here again the ratio is 10% of the horizontal force, 10% of the vertical force for the horizontal force. There are more such options for the support conditions here. For example, we have different conditions, different rules, friction Py, Pc, which is then a different way how to define the limit of Px or the maximum force of Px. Here it's the geometrical sum of Py and Pc, or you can do this also algebraic, and then you have two friction coefficients in two directions. So this gives you more options. And if this is not enough, you have also the option to use a diagram where you can enter your own your own diagram, your own relationship between the deformation and the force. For example, if I enter here some deformation and I can say here there should be 10 kilonewton, and if I have another deformation, I have maybe 15 kilonewton or 12 kilonewton or 13, and after that there should be yielding, continuous, or stopping, or something like this, or tearing. So the spring constant now is defined by the quotient between Px and the deformation Ux. So you have a different characteristic of this support spring, and it can be symmetric or it can be also different in top and in bottom. So if you want to, you can have a different characteristic in the other direction. And those things you can do for all degrees of freedom. And the other ones we had already before, more or less. This is just failure, so it acts only in one direction, and so on. So this is the friction tool that we have implemented new in RFEM 5. By the way, there is also a, I can maybe show this on another structure later, this is also possible for elastic, or in a similar way for elastic bedded slabs, not only for nodal supports. Okay. The next little tool is related to maybe companies that deal with cranes or with cables. I made here a simple approach of a maybe crane structure, and we talk now about cables on pulleys. Often you have the situation that you need to have a cable that runs over a pulley and it doesn't transport forces in all directions. So if I enter a cable from the bottom here, going around the structures and down here and pull downward on the other end, the force in the cable should be constant. If I model it with a regular tension element only, or with a cable element, then I have a fixed connection between the two ending nodes, and I have not this effect that the cable kind of slides around this node. So in RFEM, it's possible to model such a thing, and this was done due to a wish of a company that creates or that plants or sells cranes. They have this situation very often. So to do this, I need to have a polyline. It's important to model the cable as or the rope as a polyline. So it's one unity. So the software knows here we talk about one cable. So it's fixed here and it should slide around here. This cable I change into a member, or assign a member to it. I have created here already a few cross sections, and for example we can use around 40 cross section, and I change it to a member type cable on pulleys. Now the software knows, okay, this is something special, it should kind of slide around here. I need a force at the end of the cable, a new nodal force, and I enter here, let's say 100 kilonewton. Put it down here. Okay. To compare the results to a regular model with just cables, I select the structure, Control C and Control V copies this whole model with an offset in the X, and I have twice the same model, and now I can change this member type to regular cable. Okay, when I do this, I have to perform a nonlinear analysis, and this nonlinear analysis is done in an incremental way. So we have up to 5 load increments. The software chooses this automatically, and it's nonlinear, so there's many iterations. So this will take a few seconds to get the results. Also, you can influence in the calculation parameters the maximum amount of iterations and how many load increments you want to have, but for safety reasons, the software determines this automatically in a useful way or in a way that makes sense. Okay, then we should be about done, and we can compare the results. Okay, here we see now, let's first take a look at the deformations. We see here now we have 174 millimeters on the left model with the cable on pulley, 140 millimeters on the right model, which is with cable, with regular cables. When I take a look, maybe I just show now the cross sections only, or maybe I show the member by type, which is cable and pulley. If I show now the axial forces, we see here on the left model we have almost constant 100 kilonewton. There's just a small difference which is due to numerical reasons. And on the right side we see the difference. There's 100 kilonewton here, which is pretty okay. But here we have 200 kilonewton, which is introduced due to the bending of the entire structure, and here there's an additional axial force in that cable here. So if you don't have the ability to analyze such a model, you'll get totally wrong forces in your cables if you use regular cables. So there is a quite a unique tool inside RFEM to model those cables on pulleys. This is also possible if you have several pulleys that interact, so you can go around and around and around. So it's a very, very powerful tool actually. Another feature that has to do with crane manufacturers maybe is the loading on motions or due to motions. I open another model which is part of a crane cantilever, and cranes are more or less dynamic structures, so they move, they rotate, they lift, and due to the gravity, due to the weight of the structure, we have forces that resist this motion or this acceleration. And one wish was to automatically generate the forces from those motions. And in RFEM 5 you have the option to enter here a load or create a load from movement. When I do this, I have to select which members I want to rotate. In this case I select all. I can select the translational movement, which is acceleration in one direction, or I can define a rotation. So I rotate the structure around, for example, here it is the origin point and around the global axis C. And now I can enter a angular velocity plus a angular acceleration. And I enter here 0.05 as an acceleration, and I click OK. This load is now generated inside this load case number 2 in this case, and we have here a generated load that I can anytime edit. There's also a small symbol here that's hardly seeable, but it's there. You can click on and you can edit it. So when I run the analysis, I should get some horizontal deformation from this acceleration. I get also some warning because I have large deformations in this case. And you see here from the support reactions that we have here obviously some horizontal movement, and I have already no I don't. Here I can show only the Y component of the global deformation, and I can magnify it a little bit, and you see here that the rotation is causing a force that goes into the Y direction. And of course it can be then combined with load case 1, which is a vertical force, and the combination is load case 1 and load case 2, and then you have a vertical and a horizontal movement at the same time. So very easy to enter such loads from movement into RFEM and analyze the structure then as a summary of vertical and horizontal movement. So RFEM is not only for buildings, but it's also for structures like cranes or models from plants and other engineering branches like bridges and so on. Actually, quite a significant number of our users work in this sector with cranes and transportation actually. Another load tool is deals with a set of members, and I have another small example, which is a simple grid. And in this grid, I have modeled a couple set of members, which is a linear collection of members that connect linear. So those 4 members are grouped into a so-called set of member. All the loads we can apply either to members or set of members. And there is another option, and I would like to point that out for you. If I create a new member load, I can refer the loads to members, which is the standard case. Let's enter, for example, a trapezoidal load. And I can enter it maybe from 2 to 8 kilonewton per meter over the total length of the member. Okay, if I click on the members, I get this load pattern. So beginning and ending has 2 or 8, and it's always the beginning and ending is always the beginning and the ending of the member. If I do this, referring to list of members, then I can, same load, same pattern, I can say, okay, I select a linear connecting set of members or list of members, and the beginning and ending is then referring to this list of member. And if I have already a so-called set of member, which is kind of a defined list, then I can also use this as a reference, and then it's only one click. Yeah? Here the orientation of the set of member is reversed, so I can fix it by right click on the set of member and reverse set of member orientation. Okay. It saves you time because you do not, if you cannot do it, you have to calculate the ordinate of the load here and then the ordinate of the load here and so on. It's a little bit extra work. Plus another option is, or another cool thing about it is, if I move the structure, if I move the node, let's say we change it. Yeah? You see the load is recalculated. Maybe I set the coordinate here. If I'm the enter of the origin here, if I do this with the other members, you see it doesn't really do what I want. It moves, of course, the entire member load. And the same thing is here, like with the set of member, the list of member is also independent from the position of the nodes. So it's a quite cool thing and saves you a lot of work. Another thing is that you can do, and I create another load case quickly, is you have a free load also, a free line load. Under tools, generate loads, free line load. For example, you have a wall that should be on top of this grid. We can also do it, let's say, in global to real line lengths. And I say the force at the beginning is 5 and at the end is 10. And I can pick now 2 nodes. Maybe I pick, I don't know, from here to here or to here. Yeah? Okay, and okay again. So this load is a virtual load which is on that grid, but it's not fixed to any member. So when I run the analysis, it calculates internally automatically the forces on this structure, and you get automatically redistributed force where the line load crosses a member. So it's also one tool that gives you more freedom. The next tool I'm going to show you is about so-called line grids, and I open another model, which is a regular building, 3D hall, and here I can do something nice with a so-called line grid. Line grid is new in RFEM 5. You find the object in the data navigator under guide objects, and here's line grid. I right click on it and I create a new line grid. The new line grid now needs an origin, a global position of the insertion point, and I can pick here maybe here the end in this back corner. Also, you can use the you can specify the number of spacings in X direction. X is this way, so I add now here 3 spacings, and I say here 5 meters of spacing. So you see here it adds automatically my dimension lines. The same thing I can do with the other direction, Y direction. I also choose 5 meters, and this time I have only 2. Yeah? Maybe it's 6 meters, then we meet exactly the columns here. And I can do it also in Z direction. Here I choose 3 meters, and I want to have 2 spacings. Yeah? Okay, sounds good. I can also at the same time apply some labels, which you can specify here. Now it has A, B, C, D. You can also say 1, 2, 3, 4, or you can use uppercase or lowercase. You can specify whatever you want. Okay. I click OK, and I see the same thing also in the 3D structure. The cool thing about this line grid now is that you can change it anytime. Let's say I change the spacing now to 6 meters here, and it will make your structure parametric, because I can apply the changes of the line grid to the model. If I click OK and you watch the model is changed. Actually, it's not changed because I did something wrong. Let's go back. Apply the line grid. Apply changes, but I think I did something wrong with the origin, so it just looks like it's really there, but it's not really there. Here, there's a small gap, and I need to apply the origin here, and now let's check it one more time. It should work. Okay, and what's the coordinate here? Okay. Okay, let's go back to the line grid and try one more time. I change it to 6 meters. Sorry for this. And I apply my changes, and on OK. Now the structure, no. Something is not quite okay here. Display nodes, and I need my grid points. Okay. Just give me a second. I try to fix that problem here. Do undo. And I need to show my nodes and hide the line grid. The line grid can also be hidden in the display navigator if you don't like it. You go down here and you find the guide objects and you can hide the line grid. Yeah? And now I show everything, the entire structure. Here we go. And I should be able to pick that node. And this was the problem because my nodes were not displayed. So one more try. Line grids, pick origin, and now I pick this node, which is a straight measurement dimension. And now I can say 5 meters and I change it to 6 meters. And I apply my changes in the model. And I click OK. And now you see the parametric effect. Now we have here different spacing here in the structure. Yeah? Undo all the nodes that lay in this line grid are moved according to this parameter. Actually, I wanted that all the members move, so hang on one more time, try it. Okay, okay. And I can display the line grid again. Good. I think you have got the point about the way how the line grid works and how it can make your structure parametric. The next feature I'd like to show to you is about views and how we can take advantage of the views tools in RFEM. For this, I have created another model. This is actually, you might know it from an earlier webinar, which is a 3D building consisting out of several load cases, combinations, steel, concrete building. You might have noticed in RFEM 5 we have a new navigator tree here, which is called views. And with those views you can do some specific things. First of all, there's two panes. It's called user-defined views and visibilities. User-defined views are simply saved views of the structure. So if I want to save a certain view that I have, maybe I want to cut out just one floor level here, like this, and I say, okay, I want to see only this part of the structure, and maybe I want to see results, and maybe I want to see the transparent or the non-rendered view, something like this. And this picture I like to keep, so I go to views and I save it as a new user-defined view. And I say here floor 1. Next time I keep on working with the structure, change things, change my settings of loads, results, forces, and so on. But now I would need back this view floor 1. I click here and RFEM restores this saved view. If you want to change something, you missed something, you want to rotate it, maybe you want to see it in global direction C, you can always select the view and update it or redefine it with the current view by this button. You can also refresh the current user-defined view. So you click here and it refreshes it. You can delete it and you can delete all. So basically you can save your selections and your views that you have created. This is one thing. The other thing, and it works with all the settings like loads, results, and so on. All the settings are restored. The other thing is the user-defined visibilities, which are below. Here you can set certain parts. You can structure your parts of the model. You can say here I want to see only axis A, axis B, axis C, axis D, axis E. You can check them or uncheck them, whatever you want to see. It's also possible to display the hidden objects in the background so you know where in the model you are. How to create such a user-defined view? It's quite simple. Let's say I want to create a user-defined view of here of this floor of set of beams here in here. I select my structure that I want to use for a new visibility, right mouse click on it, create new user-defined visibility. I can say this should be in the same group under access, but doesn't really fit there. So I create a new group that's called levels maybe. Okay. And I want to place it under levels and I call it level 1. Okay. So now there is a new item here and I have new group. All the levels are in one group and all the access are in another group. And now if I want to see only my level 1, I can check it here and I see it. If I want to hide the background, it's gone. Okay, now you can create, also you can compose your what you see in the main workspace from those user-defined views. So for example, I have axis B and C and level 1 checked. So now I want to know which members are in all of these user-defined views. So you have buttons here that allows you to create some kind of intersection. Show intersection of checked groups. If I click on here, I only see those members which are part of all individual user-defined visibilities. If I click here, show checked visibilities, then I get everything which is checked here. Also, it is possible to use some automatically generated visibilities. For example, I can select members by cross sections. So I can open it, and if I want to know where are all my IPE 500 sections, I click here, but I have to make sure I don't have checks up here. So those are my IPE 500. I also might to see where is my HEA 240 or where is my whatever IPE 600. So by clicking on there, you see everything that is checked here, and then you can maybe create your extract the beams that you want to see in your model. If you don't like this selection, you uncheck it, or you can cancel visibility mode with this button here. Similar things, similar options you have, for example, member by release. So all members who have a release are here. So it gives you really a good option to control your structure with these visibilities. Okay. Another cool thing which is somewhat related to visibility is that you can now show the model in different colors. If you right click in the free space, you have here colors in graphic according to material, and there's different options. Each visibility can have a different color, for example. Each cross section has an automatically defined color. So just by comparing the colors, you know, okay, the cross sections are assigned correctly or not. You see in the cross section table that each cross section has a color, and if you want to see red is, for example, IPE 500. So it's a very, very good way to check your structure. You can set up in the display properties the colors that you want to use for your model. You find here a category objects by color, and if you go to cross sections, you can change the cross section color as you like, and you can just double click on it and you can manipulate the color. This is also true for other types. Okay, in the materials, you have another new feature. We can add a texture. So each material can have a texture which has some more visible or visual effects. Concrete looks then textures like concrete. I think where you can enable it is in the display, in the model, lighting, no. Let me take a look. You can enable, disable those effects. I think it's with the materials, I'm sorry. When I go here, material, and I go into the My library, better to do it here. And here you have color and edit, and you can also change the texture here and show the texture here. Do the same thing here. Mix texture with color. Okay, display textures in solid model. If I do this, okay, and I go to the solid model, and I need to display colors by material, then you see the texture in the material as well. It's only visual things, not so important, I think, for everyday life, but it's possible to do stuff like this now in RFEM 5. And sometimes it's needed, sometimes you have, sometimes it's a good thing if you can do this. Okay. Next feature has again to do with visibilities, because you can do more stuff with it. I go to the wireframe model and I show now the axis A only. And axis A, and I don't want those. I also hide my set of members. One set of members. Okay. I go to the view in negative X direction. Here we go. Okay, now I have this picture and I show here some results, maybe some bending moments. Yeah, and I have results of all the combinations. I have done this before. Maybe not everything is calculated. Calculate to calculate, and I want to calculate 3 more combinations. Okay, this will take now a few seconds. The visibilities can be used also for printing. In earlier versions, when you printed the graphic, it was more or less not so intelligent, I would say. If you added something of a graphic, if you only printed, for example, this one first frame, and you changed something in this first frame, the graphics were not updated so easily. Visibilities can help us here. So first I print into the printout report this graphic. I use a mass print option. With mass print, which is also new in RFEM 5, I can say, please print all member internal forces that I check here, MN, VC, shear force, and bending moment, of all or selected combinations. I have here 13 combinations into the printout report. So if I do this, it will use 50% of one page. I get these pictures not only for combination 2, but for all combinations I selected, plus I get the same pictures for shear force and for axial force. So if I click on this, I had, I think, 10 combinations. Times 3 is something like 30 graphics that have been created by now. If I go to the printout report, I can open it and I will see those graphics that have been automatically created by this mass print option. It saves you a lot of time because if you print every picture manually, it's a lot of clicking and quite time consuming. So we see here combination 1, 3 graphics. Yeah? In the printout report, I can zoom in and I get 2 pages on one screen. So you see many graphics have been created. Okay, it's a lot of work. Everything is here, looks really nice. Would be a pity if I lose this information because now we have a demand that we have to enter here a crossbeam for whatever reason. And how to do this and how to save my graphics. Okay, I'm still in the visibility mode. I can say now I add new object into visibility and I have to say to which visibility. And I choose axis A. And now I enter a new member. I pick a template. So I can pick this member and all the properties of this member, including the section and hinges, material and so on, are filled into the dialog. One click. On OK, it will delete my results. And now I can enter my new member. Yeah? It will go into the visibility. So I'm still in visibility axis A because I checked here. Yeah? And now if I calculate my results and I take a look at my printout report, we should still get the preserved graphics. Takes a few seconds now to get the results again, but if you know this and you work with this methodology, you will be saving a lot of time and it will help to keep your protocol up to date automatically. It is something that can be saving hours and hours of work. So I have a few more features that I would like to show you after this, and also I want to talk about how to split and or not have to split members, because what I did now did not split my column. So just a few seconds for these combinations to finish. You see here also the diagram of the maximum displacement. If you want to, you can maximize it so it will be displayed here in a bigger picture. It's good to know to see the iteration process, how many iterations are done. If it's endless, you know most likely there's some problem in your model. If there's only like 4 iterations, then everything seems to be okay for such type of structures. If you have non-linearities, there can be many more. So let's look at our printout report. We have here now new members and new internal forces and see if our graphics are still all up to date. So you might have noticed also I don't open the printout report each time I print something there. I mean, building the printout report is quite time consuming, and you should not always print and take a look at it right away. So it's more like thought to be used like create it, print everything, dump everything in the printout report, and then work and select, make your selection work at the end. You see here now we have the new beams in there, and we have all the members updated and everything is preserved and nothing is lost. Okay, this was the topic visibilities in RFEM, which is quite a big point inside RFEM 5 now, together with the mass print function. You see here what I was telling you before. You see here when we select this column, it's still one piece. So it's not, when I was entering this crossbeam, it was not divided. This is due to a setting in the mesh settings. Here at the bottom left corner, you have a checkbox that allows you to set that this member is not divided, but it's still meshed. So each time RFEM finds a node that is laying on top of a line or a member, and it will mesh it if this check is there. You can prevent RFEM from doing this by right-click on it and say Auto Connect Lines Members. If this check is on and you do the same thing that I did before, it will split the member in two lines. Also, sometimes it is difficult because, or it's dangerous because when you drag and drop things, you can select it and click and then drag it away. It will delete the results, and sometimes if you're not careful, it will, maybe you do this accidentally. If you want to forbid this accidental dragging, also right-click, and you see here enable drag and drop. You can disable it. If you disable it, you cannot drag and drop anything anymore. If you want to, you can also lock guidelines or lock the line grids. So if they are locked, you cannot edit them. Here in the right mouse key you find these options. Okay. Another new feature which is new in RFEM 5 is the so-called clipping plane. I go back to the full display. I can insert a clipping plane. Let's maybe take a look at results and maybe some forces, maybe mx or my. So now I would like to see on this level down here, but I can't see it because I have to make a visibility or whatever. How to do it? You can go and you can insert a so-called clipping plane, maybe in XY, and now I can kind of navigate through my structure. Yeah? I can change here the offset, and you can see and you can look in there and you can explore everything which is in there. You can do this in vertical, or you can do it also in or horizontal or in vertical direction. So it's also nice to look inside your building, inside your structure. Or if you have a solid model, you can look inside the solid, which is also very important. Okay, this was the clipping plane, new feature in RFEM 5. Another little feature, which is maybe also you might say you might not need it, or it's a little bit maybe it's like a toy, but sometimes you need to present your work, and presenting your work needs to have visual impressions. So you can insert so-called visual objects. For example, if I need to have the relation to some reality, here I don't know how high really this column is, but I insert a 3ds file, which is a graphical format, 3D Studio Max from AutoCAD. You can find those files very often in the internet. I can insert, for example, something like this. Select the insertion point. Maybe I need to have a multiplier, and I can enter it, for example, here, and click OK, and the men are sitting here. Maybe, okay, I don't want to have them run against the column, so I can change the position to Y position, maybe to 5 meters. Okay, and then you see here, and you see, okay, the door, how it looks like when people are in the building. Can be useful for demonstrating some things. I have one more item or two more items to show you that deal with results. It's something that's asked pretty often actually on our support. Let's stay here with this model for a little bit more, and I want to show now the floors only, and I want to see some results. Maybe I use a combination so I don't have to analyze it again, and I want to use this view. Okay, maybe not deformation, but such a result. And I want to have also this. But this is not about, well, first thing I would like to show you is about how to read results now. Now I have the graphical scale here, and I can also show numerical values if I want to, but sometimes it's nice to just zoom around and move around here and read the results. This can be done under Tools, Info about Objects. If I go here, I can hover over the beam and I can read all my information here on the beam. Same thing if I hover over the hang on, why is it doing this now? If I hover over the surface, then we see here also information about the surface, what type it is, what thickness it is, and so on. Yeah? So it's also a good feature to acquire information from. You see here the actual value where you are on the location. Yeah? So you can read your values along the structure. Okay, this is this tool info about member or surface. And the next thing is people would like to have, I close this now, people would like to have result tables from member ends so they can design the connections. And how to export this? Often you do this not in your own company, but you do this when somebody else does the connection design. But you need to deliver forces for those engineers. Yeah? For example, I have here many beams inside this first level here, and I'll create a visibility by window. So I check my level here and say, okay, I only want to look at this level, and I hide the rest of my structure. Also don't need a grid. So I run the analysis of the ultimate limit state, and then we take a look at the results, and we create an Excel table of the member end forces. So in a second we have it. Here we have the member end forces of these result combinations. Actually there's two values, there's a max and a min curve. Yeah? The corresponding table of the results can be shown here, and I go to the result tables. And here I have set of member internal forces. So this set of members also have an own table that show you the results referring to the set of members. Yeah? So there's beginning and ending. So how I want to have now the forces, let's start with the members first. I want to have the forces, members internal forces. I want to have the forces of all those members and want to give them to an engineer who does the connections. Okay, I can select them, and I can say here, please only show me results for the selected part in the graphics. So here is show selected objects only. And then I can work with filters where we have extreme nodal values. We have now a result combination, extreme nodal values. We check what we want. Maybe I don't want torsion, no? Or I want it. And I can say, please show me the extreme values on the nodes. No? If I click OK, then only the selected members are there. For example, member number 9 is missing. We have beginning at 0, ending 0, ending, no? And we get all this table. and we can export it to Excel, and we get a table with the selected objects, and that has the forces at beginning and ending of these members. And this table I can give to my engineer who does the connections. Okay, the next thing is, if I want to do this for a set of members, I click here, and the same thing happens here. You have the filter, set of member, extreme nodal values, and you can do it in the same way. If you do not use the filter, you say all the values, extreme values, and so on. Okay, then the table will be much longer, and you get more information, which is the default setting. When if you don't use the filter, it's set to something like this. You can do this independent from result combination or for load and load combination. Result combination is something like the envelope of several combinations. And if you want to know more about how to enter models and how to work with modeling and enter loads and techniques, how to work with RFEM, I have to refer you to other webinars that we did in the past that are visible on our website. Today I was only picking out a few specialties, and I'm already at the end of my presentation inside RFEM, and before we separate, I would like to show to you or give you some more hints on our website. You can find many useful informations, including videos on YouTube, for example. You find here, that takes you right away to our YouTube channel. You find here other videos, and you can download a 30-day trial version of RFEM on our download page. Also, when you do this, I want to point out the first steps page for beginners, which gives you information where to find tutorials, introductory examples that help you to get familiar with RFEM. Webinars like this are also very helpful. The next webinar is already online. It will be on December 4th, and it will be covering the Bing workflow using RFEM and Revit structure. You can sign up for it already now. I would be very happy if I could welcome you again back to one of those webinar sessions. Yes, I already introduced the upcoming webinar, so if you're ready for it, you can sign up already now. We will do something like this or similar like this. This ends my webinar of today. Robert Vogel was answering plenty of questions. I would like to thank him for assisting me here with this webinar and answering those questions. And yeah, thank you very much for being part of the webinar today. I hope to see you again for the next webinar. And if you have any questions or anything you'd like to know about RFEM, do not hesitate to contact us at info@dlubal.com. Thank you and goodbye.